safer side, right? See, MCQs, I understand some of the MCQs were different. Let me discuss the things where you went wrong. And see, you will yourself realize the questions weren't so tough. You have just committed some slight errors. Mainly your marks were gone because of the last two questions. That's it. MCQs, I understand 3 questions were wrong. Did you check, did you see the scores and the sheet back?
Yes, ma'am.
Okay. Let me discuss this. So see, the first question, Basmi, remember when vector is given, okay, when you have the vector quantity present, then you will not include the signs. It is saying electric dipole due to equatorial plane. We write it as minus Kp by r cube. Understood. But that time, this is the magnitude. Correct? This time, if in the question it is saying no dipole vector P, so it means it is mentioning the vector over here. So when vector is there, you need not mention, right? So see, when vector is there, P is the vector. So if you have a vector quantity with you, right? If you have a vector quantity with you, you have to mention you don't have to mention anything, right? But when you write its magnitude, when we write this P as the magnitude, then we need to mention the sign, correct? Now in this, it is saying, so that's why these options, this part I understand, this was a little bit confusing and it can be confusing because someday here they have mentioned the arrows, here they have not mentioned the arrows. This was fine. Second question, third was done very.
What was the answer for the first one?
Answer would be A.
Yes. Okay, ma'am.
Okay. Fourth was done fine. Fifth was correct. Sixth was also right. Seventh, C, electric field intensity due to a dipole. In both the formula, you have Kp by R cube. One formula is Kp by R cube or other formula is 2 Kp by R cube. So how is electric field related? 1 by R cube. Why did you write square? This is saying due to dipole, not due to point charge. Yes?
Yes, ma'am. I made a mistake. I thought
If
it's KQ by R square. That formula came to my mind, so I made a mistake there.
no, if it is point charge, then you are going to use KQ by R square. So your electric field will be inversely proportional to 1 by R square. Okay. It is saying dipole, so dipole's formula is this. Like first question, I understand it was a bit confusing. Your answer is almost right only because the options were very confusing altogether. But this question, it was clearly saying answer was C. Okay. Then eighth and ninth one. C. That's why I'm saying you have just made error in this topic only. Revise this topic first, just revise everything from the class notes, Basmi. The force due to the charge particle. See, vertical height is given, electric field is given, this height, that height, everything is given. Finally, when you have the, what's the question? The time of fall of electron in comparison to the time of fall of proton. I told you that the questions often give this. They always compare electron and protons together. Here also in this question also, see, it is saying time of fall of electron in comparison to the time of fall of proton. Look, when you have the time, we calculated this as 2 into mass into distance divided by charge into electric field. This was it, what we were getting after our conclusion. So I also told you that time is directly proportional to root of mass. If mass of proton is greater than mass of electron, time of proton will also be greater than time of electron. So it will be time of fall of electron will be lesser, equal, 5 times greater, 10. You tell me what should be the answer now.
Smaller.
Smaller. Exactly. So is this something new that I'm telling you right now? It is smaller. Now you told me it's smaller. Got it? So I think this topic is just weak. From the paper that I could conclude your dipole part is strong. Your dipole part is perfect now. You'll be able to manage dipole. Just revise this topic and the 2-3 questions which we practiced in the class. Everything is, see, I didn't even calculate anything. When you will write this will come out. This is what will come out. If time of electron is lesser, smaller than it, how are we getting 5? How are we getting 10? okay, equal when the masses were equal. Mass of proton is greater, larger is also not given, right? So this is clear.
Yes, ma'am.
So these were the mistakes in your MCQs. Then rest of these questions were absolutely correct. One thing, dipole में direction लिखना है Basmi. Okay, it's a vector quantity.
Yes, ma'am.
Vectors have this meaning only, that a vector, a quantity is said to be a vector when it has a magnitude, it has a direction, and it obeys the vector laws. So even if the question is asking you, it's not asking you, you did this question in the, I gave this homework question as a homework also. Remember, the same
Yes,
question I've
ma'am.
given as a homework. That time I also told you that mention the directions. Why am I emphasizing so much on this is because in your CBSE, it has some marking scheme which will be followed in your board exams. And these things you will have to remember, because see what will happen is, when we say this is a vector quantity, so some marks will be put for its calculation. When we say it has a direction, so some marks will be put for the direction. Direction is not mentioned, half mark can be cut. Okay, there are chances that marks, not a single mark is cut. There are chances, but there are chances that the marks can be cut also, because vector is incomplete without the direction. So you have a habit from the first chapter, keep it a habit of writing the direction for the vectors. That's why I emphasized on the direction so much in the superposition also. Two things remember where you can be better than others. Units, SI units, mention the SI units. Second, mention the directions for vectors. If it's a
Okay,
vector.
ma'am.
Okay, just this is how your paper will look better than others. Correct. Then
Yes.
otherwise the calculations part of all these things were absolutely right. These things you did well. Now coming to the 14th question. Now again, nth time Basmi. This is the same question. An electron moves a distance 6 centimeter when accelerated by electric field this. Calculate time of the travel, mass is given, charge is given. Time, after that calculation, how you have to start. S is equal to ut plus half at square will come. This is 0, right? Because there is no initial velocity mentioned. When initial velocity is not mentioned, then how will you assume? Like we'll assume that it is at rest. When you have S is equal to half at square, if you have this equal to half at square, your distance is half the electronic charge into electric field divided by the mass of electron into the square of time. Again, see Basmi, what do we have? 2me into d divided by e by e. That's it. So mass of electron is already given, and I've told you, remember the mass of electron and proton. At least do this much, that remember the mass of electrons and protons. Okay. Distance is
Ma'am.
6 centimeter. Electronic charge, you already know from the first class. You remember it also in the question, everything is given. Electric field is given.
Ma'am,
Why
actually,
didn't you
I did that question. I actually did that question. I forgot to scan and send. That's why it didn't come.
you didn't share this?
Yes, ma'am. I realized it after it did, after it corrected and it came out.
Okay then. Okay. And 15th one you couldn't. 15th one let me
Yes,
discuss.
ma'am.
Okay then, Basmi. If you have attempted it, then it's okay.
I'll just share with you the answer. So can you just check whether it's right or wrong?
Okay. See, in this question, force experienced by a unit charge when it is placed at a distance of 0.1 meters, okay, from the middle of the electric dipole on the axial line is given as 0.025 Newton. Okay, so what is this? This is the force experienced by the charge. So distance is given. Now, it is saying when it is placed at a distance of this much, force is this much. Malab distance is this, so force is this. If this is the distance, this is the force. Dipole's length is this. So this is an important question. So I'll tell you how to do. You have electric field across the axial line as 1 over 4 pi epsilon naught 2 kp r by r square minus a square whole square. Right? This is how we write it. This is the formula.
Yes,
So in
ma'am.
the first case, we have the value of R as 0.1 and A is not given. That's what we need to calculate. We need to calculate the dipole's length. And what is the length of a dipole in the formula? Huh? It's
R
2A,
square
2A,
R R.
2A.
Yeah,
We,
dipole, yeah, 2A.
yeah, 2A. And this A that we take in our calculation, this is actually half of it. So if we get A, we'll calculate 2A, right? So in the first case, you will have 0.025. This is the electric field. Okay, this is the force experienced by unit charge. So this is the electric field given to us. One more thing. See what the question is saying here. It is the force experienced by unit charge. This is what the definition of electric field. It basically means that F is equal to Q. F is equal to Q into E, right? Electric field, you don't know. So electric field is force by Q. What is the force given? 0.025. What's the charge? Unit charge means 1. So that is the definition of electric field. I made you write in the notes also. Force experienced by unit charge. So when you put the value unit, force, that becomes, this is the electric field Newton per coulomb. Got it?
Yes, ma'am.
Properly, is this clear? Why am I taking this as electric field?
Yes, ma'am.
First of all, the definition is given. Force experienced by unit charge is given. Second of all, if I calculate also by the calculation, force is this, charge is unit. So I get this much Newton per coulomb as the electric field. So basically, both of these are electric field only because charge is 1 unit. If charge is different, it will give you in the question. That force experienced by 2 coulomb charge is like this. Then you put 2 here, whatever is the value of charge given. So electric field is 2. Now K is 9 into 10 to the power 9. 2K. Dipole moment we don't know. Is it given electron?
No, ma'am.
No, it's not given. The electron is meant. So let's just write it as P only. Because we don't know. We can calculate the dipole eventually. R is given as 0.1 divided by, this is R square minus A square, means you have 0.1 whole square minus A square to the power whole square. Like this. This is your first equation. Second equation will be with this. 0.002 is equal to, again, 2 into 9 into 10 to the power 9 into P. Dipole will be the same, correct? So it will be P
Yes,
into
ma'am.
R is 0.2 this time, divided by 0.2 whole square minus 0, A we don't know, A whole square. Look, 2 variables are there, 2 equations are there. This is P or A. You calculate anything, you will get the value. See, if I take the ratio of these, this will be like 0.025 divided by 0.02. 0.02 or
0.0.
One more zero is there. 0.002. This is equal to C. Distance will be left. 2 kp will be cancelled from both the sides. When you take the ratio, it will be cancelled. From the numerator, only this distance will be left, right?
Yes, ma'am.
And the denominator. So 0.1's denominator will be here and 0.2's denominator will go up. So this, and this was 0.1 whole square minus A square to the power whole square. This is given. So zeros get cancelled, this gets cancelled, this gets multiplied 50. So you have 25 by 2 is equal to 1 by 2. 2 gets cancelled, so you have 25. So when you square this, so this becomes 5 here. This is 0.04 minus A square divided by, this is, I have taken the square root. I hope you've understood what I have done. Let me
Yes,
read.
ma'am.
You've understood, na? I have just seen these, here were the zeros. So basically, this 2, when we remove the decimals from here, here, this 2 gets cancelled. So I have taken the root on both the sides. So 5 from here. And when I square this, 0.04 minus a square is left, divided by 0.01 minus a square is left. So it will be 0.05 meters. So this is a. So 2a will be 0.1 meters. That will be the answer, 0.1 meter. Got it?
Yes, ma'am.
Okay, so this was a good question to be discussed. And that score, that question 14 carried how many marks?
Marks.
So 3 marks were cut. So it must be 16.5 around something. Chalo, koi nahi. Write this solution, then we'll continue with potential, okay? Is this clear, this question?
Okay, ma'am.
Okay,
Yes,
Basmi, right.
ma'am.
And your homeworks are also pending now from last class. Only I've received the Gauss theorem one was the last one.
Ma'am, I submitted it today morning.
Morning you have given?
Yes, ma'am. Oh, I didn't submit it. I'll submit it now, ma'am.
Right, though you have not submitted, I've checked it. Okay. Share it, then I'll.
Ma'am, I'm done.
So look, we started with the chapter in the last class, electric potential and capacitance. And we have seen that electric potential is what? Basically, when you have a test charge and you are transferring its position from infinity to a point. And when you are transferring a charge between 2 points, it is called potential difference. These are the things we studied. And we were discussing that it's a property of a single charge. This is the formula for it. V is done by the charge, and it's a scalar quantity. SI unit is volt. Due to a point charge we have calculated, V is equal to KQ by R. We did the superposition principle. We have to practice a question also on this, that V1 plus V2 plus V3 will give you the net. Yeah, I was discussing when you have the work done due to electric field and you have to calculate the work done due to external or vice versa, just multiply it with a negative sign. Like I'll show you a question. This we were supposed to start from this. Calculate work done by electric field in carrying a charge from A to point B. Now we know the work done by the external force. So work done by the external force, it will be charge multiplied to the change in potential. So charge is 2 coulomb, change in potential. See, final potential is 15, initial potential is 5. So this will be 2 into 10, that is 20 joules. So when you're calculating the work done by the electric field, it will be negative of work done by the external force. So work done by the electric field will be minus 20 joules. Clear? You've
Yes,
understood
ma'am.
this? Okay, write it. Then we'll see some more things.
I'm done.
Okay. See, this is one question which is based on the superposition principle. 4 charges are there, plus E, minus E, 2E, minus 2. Now it is saying calculate the potential at O, then E, and then work done. Let's see the first part. Now at O, see side is A. So what will be AO equal to? Yes, side is A.
Root 2. A root 2.
A root 2, correct. A root 2 or no, that is AC. I'm asking AO.
Oh, A by root 2.
A by root 2. Okay, diagonal is, this diagonal part is 2A. So half of it will become A by root 2. Now, Basmi, you tell me what will be the potential due to A at point O.
Potential due to A at point O.
Yes, due to A. This is A. It's a point
Well,
charge.
so towards C, right?
Direction is not there. Potential is a scalar quantity. I'm just asking the magnitude. There is no direction.
Okay, ma'am.
So what's the formula of potential due to a point charge?
KQ by R.
Exactly. So apply the same thing here. At O due to A.
K,
K.
K into 1.6
Just take E. Take E.
E by
Divided by
A by root 2.
A by 2. Correct. A by root 2. Similarly, tell me for B. VB.
VB,
Hmm?
it's minus KE
Yes, very
by
correct. By A by root 2. Because it
A
is
by
a
root 2.
scalar quantity. Similarly, VC will be
K2E by A by root 2.
correct. K into 2E by A by root 2. And VD will be
2K2, wait, what? Minus 2E
correct.
K by A by root 2.
Right, right. Absolutely correct. Now see, when we have the net potential here, we don't have to see the direction, anything, nothing we have to check. We can simply add it, subtract it. That's what our superposition principle for potential. So look here. This will be KE by A by root 2 minus KE by A by root 2 plus 2KE by A by root 2 minus 2KE by A by root 2. This gets cancelled, this cancels this side, this cancels this. So this is 0. The net potential is 0 at center O. First part is clear?
Yes, ma'am.
Okay, now it is saying at this point E, you have to calculate the potential. So E is in the midpoint of BC. So look here, if this is A, total is A, so this part will become A by 2. This is A. How will I get AE? Pythagoras theorem? Look, second is like this. You have A, E. This is A by 2. This is A. We want this. A, E or D, E both will be equal to it. So when we apply the Pythagoras theorem for AE square will be A by 2 whole square plus A square. So this becomes A square by 4 plus A square. So the side AE is equal to under root 4A square plus A square by 4. So AE is equal to 5A square by 4 under root. So this is equal to A by 2 root 5. Clear?
Yes, ma'am.
So similarly, AE is this, which is equal to DE also. Both of them have the same separation. Look, this DE also. Because I want to calculate at point E due to all of the charges. Now look, E point is here. This is A point. So what will be the potential at E due to A?
KE by AE.
KE by?
A by 2 root 5.
Exactly this term, AD. Correct. And if I say what will be the potential due to C on E, tell me.
That will be K2E by A by 2.
A by 2. Perfect. So similarly, we will calculate now for all of it. This is the second part. So VA will be, it is KE by A root 5 2 will go up, right? Similarly, VB is plus E? No, minus E. Minus E and separation is A by 2. So minus KE by A by 2. So 2 will go up. VC is the same. Sign is different. Charge is 2E. So VC is 2KE by A by 2. So it will become 4. 2 into 2. And what about VD is minus E?
Yes, ma'am.
Minus 2E. Minus 2E. So this will become minus 2KE by A root 5 and then 2 will go up. Means this will also become 4. This is clear till here? All 4 of
Yes,
these?
ma'am.
So
Yes,
now we'll
ma'am.
just add them. For the net potential, we'll simply add it. So 2KE by A root 5 minus 2KE by A plus 4KE by A minus 4KE by A root 5. Okay. So this will be equal to, see, let's take 2KE by A common. 2KE by is there everywhere. So 2KE by A. So from here we'll be left with 1 by root 5. 2KE by, from here minus 1.
One,
From here
plus
2.
2
From here
minus 2 by root 5.
correct, minus 2 by root 5. So see, this will simply be 2KE by A. Look, this is 2 minus 1. That is 1 only. And this is 1 minus 2. Basically, the denominator here is root 5. And 1 minus 2, that is minus 1. Got it? This part.
Yes, ma'am.
So the net potential will be equal to this. Now the third part is the same. This was the first part. Work done in carrying proton from O to E means center to this. So when you are calculating the work done due to it, you take the change in potential. So work done will be carrying the charge proton. So you know the charge on the proton is E. Look, what's the third part? When you are asked to calculate the work done is charge multiplied to change in potential. So charge is the protonic charge. What's the charge on a proton? E. Change in potential, final potential minus initial potential. Now, final potential means at point E, initial potential means at point O. So at point O, our net potential was 0. So our answer will be, this work done will be E gets multiplied to this whole term. So that will be 2KE square A 1 minus 1 by root 5 this much of joules. This is this much of volts. This is the work done.
Why do we take Q as E?
Why did we take
Q as E.
Q as E proton?
As,
Proton is given in the question.
oh, okay, ma'am.
Okay, that's why Q as E we have taken. Got it?
Yes, ma'am.
Okay, please write down this one also. See this proton given.
Mm. Ma'am, can you scroll down? Ma'am, can you scroll down? Ma'am, can you scroll down?